I've worked on a lot of games. Most of them have been for various game jams, where I've been forced to create something interesting within a short time frame. Something about game jams have always drawn me to them, and I finally think I've understood why. You see, when I make games, there is one thing that I find distinctly more interesting than anything else: prototyping. I love to invent new solutions and implement them into my projects. Perhaps the most fun part of prototyping is mixing and matching different prototypes. This is an incredibly fun way of finding interesting gameplay mechanics and really makes me feel creative. My name's Simon Holmqvist, and at my core, I'm not really a game developer. I'm a mad scientist. As a recently self-diagnosed mad scientist, I decided to embark on a journey of innovation. Having found a deep love for KSP, I've decided to make rockets in Unity. Can't be that hard, it's not rocket science or anything. But in all seriousness, that's exactly why I chose it. I really do put emphasis on the word mad in mad scientist. Rockets are cool, not only because they are a gigantic fire-spitting explosives, but also because of what that implies. Many of the world's smartest people have worked to create something so groundbreaking that their fieldwork has become a literal synonym for something difficult to understand. That, my friends, is humanity at its best. Rockets put men on the goddamn moon! Don't tell me that isn't awesome! Thus, I've decided to take a minuscule nibble out of the massive steak that is rocket science and begin work on my very own rockets. Probably the most interesting part of a rocket is its engines. Everything from the tiny iron engines of satellites to the gigantic F1s that pushed the Saturn V through the atmosphere are undeniably awesome. One of the most iconic rocket engines is the RS-25, also known as the Space Shuttle Main Engine. It's the one that sat right here on the Space Shuttle, and also the one that NASA plans to use on the core stage of the SLS, which is planned to take humans back to the moon this decade. There are good pictures of the RS-25 as well as some very detailed statistics, which is why I chose to make it the first engine for my project. After spending a couple hours in Blender, I managed to create this 3D model of the RS-25. It's obviously not identical to the real thing, but I think that one would at least be able to recognize what it's meant to mimic. If you look closely, you can see the engine controller, the combustion chamber and some turbo pumps. After getting the model into Unity, I gave it some simple materials and started working on the mock diamonds. Wait a second. Mock diamonds? What on earth could have such a badass name? Well, mock diamonds, also known as shock diamonds or thrust diamonds, are the plume of supersonic exhaust that can often be seen behind jets and rockets. When you see them, it's easy to figure out where the name came from. Lower pressure gas gets compressed in high pressure gas, then expands again into low pressure gas, creating these beautiful patterns. Recreating them in Unity was quite the challenge. I tried to use force fields to simulate where the plume tightened, but they ended up looking really weird in play mode. What I managed to create looks really good in my opinion, but I'd love to improve them in the future. The main effect was accomplished by scaling the particles up and down during the lifetime, and then applying a negative radial velocity. I also created this glowy particle in GIMP that I slapped onto the particle system. Nice! So, now I had a rocket engine and a beautiful plume, but where was the exhaust coming from? I figured that it was about time to create a propellant tank. And so I did. The orange color is supposed to represent the foam that can be seen on, for example, the external tank of the Space Shuttle. The sprayed on foam was originally yellow but turned orange after being exposed to UV light. I now plan to create different types of tanks for the fuel and oxidizer, so the propellant tank is really two tanks in one piece. You see, engines like the RS-25 use a reaction between fuel and oxidizer to shoot hot gas at insane speeds to the rocket nozzle. That means that they need at least two tanks, one for the oxidizer and one for the fuel. The fuel in this case was liquid hydrogen, but other engines may use other types of fuel. I knew that I wanted to be able to easily add more engines in the future, so I created a quick data structure to organize all important information as I wanted to. At the core of this structure are scriptable objects. They are a great way to store information about different things in the same category, such as different types of engines. I was thrilled when I found out that NASA has an open database of thousands of amazing images, videos and sounds that anyone can use. The sounds that I used for the RS-25 from a real test performed in 2017. I made one sound for the ignition, and one sound for when the engine is just continuously burning. Threw them into Unity and added them to the scriptable objects. Finally, I had all the information that I needed to start work on implementing the physics. There is this really neat function in Unity called add force add position, which automatically applies the torque that is created when a force is applied somewhere other than the center of mass. I, however, did not know of this function, and instead decided to manually implement the torque using the add torque function. At the time of programming the physics, we were being introduced to classical mechanics in school. We'd learned about the basic forces, Newton's laws, and most recently, torque. Eager to wield the power of knowledge, I let my fingers run rampant on the keyboard. After hours of intense coding and definitely no googling, I had this. Pretty cool, eh? I added a nice gimbal for the engine so that I could somewhat steer myself towards my destination. It's a bit hard though, since I haven't implemented any atmosphere system yet. When I finally do, I will be able to create fins and such to control the rocket more precisely. Now that I have my cool orange stick ready, I just needed someone to pilot it. Traditionally, astronauts sit in a command pod on top of the tanks. This, however, is too safe and thus not fun enough. I wanted my pilot clinging onto the side of the rocket like Tom Cruise in Mission Impossible. For that to be possible, my pilot would need some killer athletic abilities. Unfortunately, he was very immobile. It was due time to give him some gains, and by give him some gains, I mean jump right into
character controller hell.
I went with a built-in character controller component for this project. I tried to use a rigid body as I normally do, but for some reason it just did not want to work. But to be fair, neither did the character controller component at first. Got stuck on every ledge, was able to climb insanely steep slopes, and wasn't detecting the ground properly. Most of these problems turned out to be solvable, although I still needed to work on some minor details. 4 things that I used a lot were the dot product, the cross product, raycast normals, and the vector3.angle function. Here's a quick rundown on all of them. The dot product has a lot of cool uses, but I only use it to calculate how different 2 vectors are. If the result of the dot product is negative, then one vector is pointing more than 90 degrees away from the other. In 3D space, the cross product is often used to find a vector that's perpendicular to 2 others. In reality, there are 2 such vectors, but the cross product selects one according to the left-hand rule. That means that if you do this thing with your hand, your index finger is B, your thumb is A, and your middle finger is the result. The raycast normal is simply the normal of the surface that you hit with your raycast, and finally, vector3.angle gives you the angle in degrees between 2 vectors. Whew, that was fast. I'm usually more thorough in my explanation of things, but right now I'm in such an early phase of development that any detailed commentary on my code will be more confusing than informative. If you're looking for some more in-depth videos, be sure to subscribe so that you won't miss them when they are uploaded. I have more plans for my LOD planet, and I'm eager to continue working on it. Anyway, all these 4 things combined create a decent ledge handling, slope respecting character controller. The controller also has this awesome mega jump, which allows it to jump up and grab the rocket. If it does, it is able to climb around it until the player finds a good spot to sit. Right about here seems good. Now, if the player presses the button E, vehicle control mode is toggled on. The rocket is now being controlled instead of the character. As you can see, I am very much inspired by KSP, but what I'm working on is far from the same thing. My big dream is to be able to jump between multiple rockets, airplanes and cars, taking out the pilots, having intense close combat fights with other players on top of the moving vehicles, and just have this insane sense of movement that constantly creates new and interesting opportunities. Imagine a dogfighting game where the players constantly jump between different jets. But this might very well change in the future, and that's the point. I don't want to be limited by the decisions that I make before even building anything. I want to let myself be guided by what feels fun and interesting, motivated to learn new things. Hopefully, this will lead to better projects and more rewarding development processes. And that's about it for this video. If you enjoyed it and would like to see more, you know what to do. All the buttons should be where they usually are unless something has gone terribly wrong, which I hope it hasn't. If you have any questions, feedback or just want to chat, feel free to leave a comment down below. I wish you all a great day. Bye.